In this video, we'll be discussing on asymmetric key algorithm, specifically RSA algorithm. So at the end of this lecture, you will be able to perform encryption and decryption using RSA algorithm. So as the name itself tells, asymmetric key, two different keys are used, a public key and a private key. So you can refer this topic from the textbook Cryptography and Network Security by Atul Kahate. Right. So RSA algorithm was actually developed by Ron Rivest, Eddie Shammer and Len Edelman at MIT as a good cryptographic system. So the name RSA stands behind their name, Rivest, Shammer and Edelman. So this algorithm solves the problem of key agreement and distribution. So in this algorithm, both the communicating party will possess a pair of key made up of a public and a private key. So this is most popular asymmetric key algorithm that employs prime numbers. Fine. We'll discuss on how the algorithm works. So initially, select P and Q to be large prime numbers. P and Q may not be equal. You will have to choose two different prime numbers P and Q, the two very large. Then you will calculate the value of n, which is equal to P multiplied by Q. Then calculate phi of n, where phi of n is equal to P minus 1 into Q minus 1. Then you will select a random E value. So the value of E should be such that the greatest common divisor of phi of n and E should be equal to 1, and at the same time the value of E should be between 1 and phi of n. Means it should be larger than 1, at the same time should be a value which is less than phi of n. Once the value of E is known, you can calculate D with the formula D into E congruent 1 mod phi of n. So having this, you will be able to calculate the public key E comma n and private key D comma n. Let me show you an example so that you will better understand the algorithm. Imagine you have chosen P value to be 17 and Q value to be 11. So you are going to calculate, or you will be finding the value of E and D, that is the public and private key. Then you will perform an encryption on the plain text 88. Okay. Okay, fine. We'll start with P and Q to be 17 and 11 respectively. So now you can calculate the value of n as P into Q, which is nothing but 17 multiplied by 11, you have as 187. Calculate phi of n, which is P minus 1 multiplied with Q minus 1. So here P is 17, so 17 minus 1 is 16, and Q is 11, so 11 minus 1 is 10. So altogether you have phi of n to be 160. So now we are supposed to calculate a random value E. So the condition tells the value of E should be GCD of E and phi of n should be equal to 1, and at the same time it should not exceed phi of n, right? So how you are going to find out is, so here actually your phi of n is actually 160. So you can choose 161, a number 1 greater than your phi of n. So if you find out to be 161, 23 into 7 is nothing but 161. So now what I am going to do is I will choose 7 to be the value of E. So if you take GCD of 7 and 160, that will be equal to 1. So once you have the value of E to be with you, you can easily calculate D using this equation. So instead of E, you will substitute 7. So D multiplied by 7 congruents 1 mod 160. So D will be equal to 7 inverse mod 160. I think you're familiar to how to calculate the inverse of 7 inverse. You can use multiplicative inverse, that is equivalent method, to calculate the value of D. So once D is known, you have your public key as well as your private key with you. Apart from that, you have numbers P and Q. So the given plain text is 88. You are supposed to calculate the cipher text for the plain text. You are going to perform encryption, right? So your public key will be 187, 7, and your private key is 187, 23. So you have your E and D values finalized. Now your job is to perform encryption. So C is your ciphertext, which is equal to message power E mod n. So in this question, you have your message to be 88 88 to the power e is 7, so 88 to the power 7 mod 187. So once you calculate and take the mod value, you will have 11. So 11 is the ciphertext. So to perform decryption, you have the equation message, that is your actual plain text, is equal to c power d mod n. So here your ciphertext is 11. So 11 to the power D is 23. So 11 to the power 23 mod 187 is nothing but 88. So you are able to perform encryption as well as decryption using RSA algorithm. Now try this problem as your homework. Select prime numbers P and Q to be 11 and 3. And now you will find out what is the public key and private key. Means you are supposed to find out what is the value of E and D. So once finding out your public and private key, you will perform encryption and decryption on the message M is equal to 7. This is your first problem. And your second problem, consider an RSA crypto system with N is equal to PQ, where P is 7 and Q is 13, and your public key be N, 35, and your private key is 5 of N, P, Q, A. You are supposed to decrypt and find out the value of 10, right? Since P and Q are known, you will be able to find out what is phi of N. And you have the public key with you. Having the public key with you, you can calculate what is your private key, and you have the equation to calculate your plain text as message, that is plain text, is equal to c power d mod n. C is nothing but the ciphertext. So your ciphertext here is 10. So 10 power d mod n. So you try to complete this problem. We will discuss in the DCS. Hope you will be able to perform encryption and decryption using RSA algorithm. We will continue in the next session. Thank you.